Hello students, today we will be solving the IB Math A HL May 2025 paper 3 time zone 1 question number 1. We are starting this paper today and we will be solving the question number 2 in our next session. You will be getting the solutions for the other solved questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve question number 1. The maximum mark is 23. This question asks you to use polynomial functions to model some situations in probability. Two unbiased tetrahedral, that is four-sided dice, with faces labeled as 1, 2, 3 and 4 are thrown and the scores are recorded. The random variable n denotes the maximum of these two scores. There are two dice, so the maximum is recorded as the random variable m. And the labels are 1, 2, 3 and 4, so the maximum can be 1, 2, 3 or 4. So these are the four values of m. And P of m equal to m is, these will be the corresponding probabilities. These are the corresponding probabilities that have been given. You don't have to find these probabilities, but in case you're curious to know how to get to these probabilities, let me show you. For this question, they are given, you don't have to actually find them. But anyway, I'm constructing the table, the grid. So this is a one dice and this one is for the second dice. Okay. When both of them are having the number 1, then the maximum number is 1. When it is between 1 and 2, the maximum is 2. Because m is recording the maximum of these two scores. So 1 and 3, it is 3, 1 and 4, 4. 2 and 1, maximum is 2. 2 and 2, maximum is 2. 2 and 3, the maximum will be 3. And 2 and 4, the maximum is 4. 3 and 1, the maximum is 3. 3 and 2, maximum 3. 3 and 3, maximum 3. 3 and 4, maximum 4. And 4 and 1, maximum 4. 4, 2, maximum 4. 4, 3, maximum 4. And 4, 4, maximum 4. So you are having 16 entries over here. Okay. And only one of them is having 1. So the probability is 1 over 16. For 2, there are 3 2s, so it is 3 over 16. For 3, 1, 2, 3, 4, 5, 5 3s. Probability is 5 over 16 and 1, 2, 3, 4, 5, 6, 7. Probability is 7 over 16. This is how you are getting the probabilities. Okay. So part A's question is find the expected value of m. So expected value of m should be equal to 1 times 1 over 16 plus 2 times 3 over 16 plus 3 times 5 over 16 plus 4 times 7 over 16. Okay, so this is equal to 1 over 16. Therefore, expected value of m is equal to 1 over 16. And okay, let me keep it this way. 6 over 16 so that I get the common denominator as 16 plus 15 over 16 and 28 over 16. Okay. So therefore, expected value, this is a paper 3 question, so you can use your calculator. So okay, so it is, I'm just adding the numerators. So 1 times 1 is 1 plus 2 times 3 is 6 plus 3 times 5 is 15 plus 4 times 7 is 28. Okay, so this is equal to 50. So this is equal to 50. 50 over 16, or this is equal to 25 over 8. You can give the expected value as 25 over 8, or you can give the equivalent decimal approximate answer, but I am keeping it this way. Okay. Alternative way to represent the probability distribution of m is to use a polynomial function g, where g of t is sigma m equal to 1 to 4, p of m equal to m times t to the power of n. Hence, for the distribution of m, g of t is equal to p of m equal to 1, because the first sigma value of m is 1. So p of m equal to 1, which is 1 over 16. So 1 over 16 times t to the power of 1. So 1 over 16 times t, plus t m equal to 2. So we will be taking this probability 3 over 16 times t square, plus 5 over 16 times t cube, and plus 7 over 16 times t to the power of 4. Subpart B is saying find g of 1. So we will be substituting 1 in place of t. So g of 1 is equal to 1 over 16 times 1 plus 3 over 16 times 1 square plus 5 over 16 times 1 cube plus 7 over 16 times 1 raised to the power of 4. So therefore, g of 1 is equal to 1 over 16 plus 3 over 16 plus 5 over 16 plus 7 over 16. Okay. So 1 plus 3, 4, 4 plus 5 is 9, 9 plus 7 is 16. So therefore, g of 1 is equal to 16 over 16, which is equal to 1. Okay. Subpart C, it is having two further subparts. The first subpart I is saying find g prime of t, the first derivative. Okay, so C I g prime of t should be equal to, we will be differentiating this with respect to t. It is 1 over 16 plus 3 over 16 times 2t plus 5 over 16 times 3t square plus 7 over 16 times 4t to the power of 3, or t cube. Okay. So I can cancel these two, and okay, and this also will be getting cancelled. So therefore, g prime of t can be written as 1 over 16 plus 3 over 8t plus 5 times 3 is 15. So 15 over 16 t square plus 7 over 4t cube. Okay. Okay. I hence showed g prime of 1 equal to the expected value of m. We have found the expected value of m as 25 over 8. Now let us find the value of g prime of 1. This is the subpart I's answer. G prime of 1 is equal to 1 over 16 plus 3 over 8 times 1 plus 15 over 16 times 1 square plus 7 over 4 times 1 cube. Okay. So this is equal to 1 over 16 plus 3 over 8. I'm trying to get the common denominator as 16. So 3 over 8 can be written as 6 over 16. I'm multiplying both the numerator and the denominator by 2. So it is 6 over 16 plus 15 over 16. And for this, I am multiplying both the numerator and the denominator by 4. So plus 28 over 16. Okay. The denominator is 16 and the numerator is 1, 6, 15 and 28. You see, for the expected value of m, the denominator is 16 and the numerator will be 1, 6, 15 and 28. So the sum total will be the same, 50 over 16. So this is equal to 50 over 16, which is equal to 25 over 8, which is equal to the expected value of e to the power of, expected value of m. Okay. So shown. A bag contains 2 red balls and 3 yellow balls. 2 balls are selected at random without replacement from the bag. The random variable x denotes the total number of red balls selected. There will be two balls selected, so number of red balls selected can be 0, 1 or 2. That means no red balls selected, 1 red ball selected or 2 red balls selected. You can have only these 3 possibilities. Okay. So the probability distribution of x can be represented by the polynomial function g of x, gx, where gx of t is equal to sigma x equal to 0 to 2, because x can be either, there can be no red ball or 1 red ball or 2 red balls. So x equal to 0 to 2, p of x equal to x and t to the power of x. So part D's question is show that gx of t equal to this, making it clear how the coefficients of gx of t have been determined. It is carrying 5 marks. Okay. So let us first of all construct the probability distribution table of x. Okay. So small x, it can be 0, it can be 1, it can be 2. Okay. And probability capital X equal to small x. That means first of all, E of x equal to 0 means no red ball. No red ball. Total number of balls is 2 plus 3 is 5. Sorry. And no red ball means there are 2 yellow balls. So x equal to 0 will be what? 3 over 5 first yellow ball and without replacement. So the second, there will be 2 yellow balls remaining and total will be 4. 4 balls. Out of those 4 balls, 2 are yellow, so it is 2 over 4. And I can cancel these 2 and I get the value as 3 over 10. Okay. So this is 3 over 10. You have to show these also. Okay. And then x equal to 1. That means 1 red ball. So red 1, yellow 1. X equal to 1. Okay. So it can be either red and then yellow or yellow and then red. Okay. So red and yellow. So it is 2 over 5 times 3 over 4, or so it is plus 3 over 5 and 2 over 4. Okay. So it is the same, 3 over 10 plus 3 over 10. So 6 over 10. 6 over 10 or 3 over 5. Okay. And 2 red balls. X equal to 2. So 2 over 5, 2 red balls, so 2 over 5 times 1 over 4. So it is 1 over 10. And always it is always better to check whether the probabilities that you have written are correct or not, because the sum total of all the probabilities has to be equal to 1. So this is 3 over 10, this is 1 over 10, so 4 over 10, and this will be 6 over 10. So 10 over 10, which is 1. This assures us that the probabilities that we have found are correct. Okay. And now we will be finding this g of x, gx of t's expression. Gx of t should be equal to sigma x equal to 0 to 2, p of x equal to small x and t to the power of x. So this should be equal to, first of all, x equal to 0. So it will be p of x equal to 0, t to the power of 0 plus p of x equal to 1 times t to the power of 1 plus p of x equal to 2 times t square. Okay. So therefore, gx of t should be equal to, p of x equal to 0 is 3 over 10. T to the power of 0 is 1. P of x equal to 1 is 3 over 5 times t to the power 1 is t. P of x equal to 2 is 1 over 10 times t square. So therefore, gx of t is equal to 3 over 10 plus 3 over 5t plus 1 over 10 t square. Okay. An unbiased coin and a biased coin are tossed. The probability of obtaining a tail on the biased coin is p. On the unbiased coin is obviously half. For the biased coin, it is p. The random variable y denotes the total number of tails. Again, the two coins are tossed, so total number of tails can be 0, 1 or 2. Okay. Obtained. So y denotes the total number of tails obtained from tossing both coins. The probability distribution of y can be represented by the polynomial function gy, where gy of t is equal to sigma y equal to 0 to 2, p of y equal to y, t to the power of y. Subpart E's question is given that the coefficient of t square or in gy of t is 1/3. Find it is having two further subparts, the value of p and an expression of gy of t. So first thing that we have to find out are the probabilities. We have to construct the probability distribution table for this random variable y. Okay. So E, let me first of all construct the table. I'm not putting one I or II at this moment. So y 0, 1 and 2. So P of y equal to small y when you don't have any tail. Both the coins are giving heads, are showing heads. Okay. So what will be the probability? Half for the unbiased coin, and because the biased coins getting a tails probability is p, so getting the head will be having the probability of 1 minus p, because the total probability has to be equal to 1. Okay. So it will be 1 minus p over 2. Okay. So this is y equal to 0. For y equal to 1, that means biased, unbiased. There is a single tail. The tail can appear in the biased coin or it can be from the unbiased coin. So it can be head and tail or tail and head. We have to consider both the cases. So this is biased and this is unbiased. So for the biased coin having a head is 1 minus p, and unbiased coin is having the tail, so it is half, or this one, so it is plus. Biased coin is having the tail, so it is p, and unbiased coin is having head, so it is half. Okay. So if we just expand this, we get half minus p over 2 plus p over 2. These two will be getting cancelled and you have the probability of half. And then it is y equal to 2. That means biased coin is having a tail and the unbiased coin is also having the tail. So the probability for the biased coin, it will be P, and for the unbiased coin, it will be half. So the probability will be P over 2. And if you add these three probabilities, you will be seeing that you are getting the sum total as 1. This confirms that the probabilities that we have written are correct. Okay. And now we write the gy of t's expression. So therefore, gy of t will be equal to 1 minus p over 2 times t to the power of 0. So I'm not writing that. Plus half times t to the power of 1. So it is plus half t plus p over 2 t square. Okay. Now we come to the I. Given that the coefficient of t square in this is 1 over 3, find the value of p. So therefore, the coefficient of t square is p over 2 is equal to 1 over 3. Implies p is equal to 2 over 3. Value of p, so it is p equal to 2 over 3. Now, an expression, find an expression of dy of t. We have found the expression of dy of t, but we did not know the value of p. So now that we know the value of p, let us rewrite the expression. It is gy of t is equal to 1 minus 2 over 3 divided by 2 plus half t plus 2 over 3 divided by 2 t square. So therefore, gy of t is equal to 1 minus 2 over 3 is 1 over 3. So this is 1 over 3 divided by 2 is 1 over 6 plus half t and 2 over 3 divided by 2. So 2 over 3 divided by 2 will be equal to 2 over 3 multiplied by half. So this will be plus 1/3 t square. Okay. For answering the subpart I, you do not actually have to construct this table. You can only get the probability of P of y equal to 2. That will be sufficient. But for I, you have to get all the probabilities. So I have constructed the table first and then I have come to the I, the subpart I. Okay. You can get the value of p first and then you can get p of y equal to 0. Over here, you can directly substitute p equal to 2 over 3. It is up to you, okay? Whether you will be first of all getting the value of p and then constructing the table, or first of all constructing the table and then coming to the answering of the two subparts of E, okay? The random variable z denotes the sum of the total number of red balls selected x and the total number of tails obtained from tossing both coins y. That means if x is equal to 1, that means 1 red ball selected and 1 tail. So the z value will be equal to 2. Okay. The probability, the z value will also be equal to 2 if no red ball is selected, that is x equal to 0 and 2 tails, or 2 red balls are selected and no tail. Okay, it can be 0 2 2 0 or 1 1. In all the three cases, the z value will be equal to 2. Okay. The probability distribution of z can be represented by the functions g of gz, where gz of t is equal to gx of t times gy of t. And the subpart F is saying for random variable z, it can be shown that gz prime of 1 equal to expected value of z. Use this result to find the expected value of z. It is carrying 4 marks. Okay. Now you can construct the probability distribution table of Z. I will be showing you for this. You really do not need to construct, but even then I will be showing you how to construct the table after I solve this apart F, because in a separate question you may be required to construct the table. So I'll be showing you the process. Okay. So first of all, let me answer this question. So gz of t is equal to gx of t times g of y of t, and therefore gz of t is equal to what was gx of t. It was 3 over 10 plus 3 over 5t plus 1 over 10 t square. Okay. So 3 over 10 plus 3 over 5t plus 1 over 10 t square times 1 over 6 plus 1 over half t plus 1 over 3 t square. Okay. 1 over 6 plus half t plus 1 over 3 t square. And we will be expanding. So this is equal to 3 over 10 times 1 over 6 will be 1 over, this is 3 and 6, they will be cancelling. So it is 1 over 20 plus 3 over 20 t plus 3 and this 3 will be cancelling. So it is 1 over 10 t square. And again 3 and this 6 cancels. So it is 1 over 10 t plus 3 over 10 t square, and this 3 will be cancelling. So it is 1 over 5 t cube plus 10 times 6 is 60, 1 over 60 t square plus 1 over 20 t cube plus 1 over 30 t to the power of 4. Okay. So this is equal to, first of all, let me write we will be writing the terms in ascending powers of the variable t. So 1 over 20 is the only constant term. So let me write that, plus it is 3 over 20 t and 1 over 10. So it is 2 over 20. So 3 plus 2 is 5. And you don't have any other term containing t. So it is 5 over 20 t. Next comes the t square. It is 1 over 10 plus 3 over 10. So 4 over 10. 4 over 10, and this is 1 over 60. So 4 over 10 can be written as, if I want to convert the 10 to 60, I have to multiply by 6. So 4 should also get multiplied by 6. So it will be 24 over 4 times 6 is 24. 24 over 60 plus 1 over 60. Okay. So 25 over 60 t square plus t cube is 1 over 5 and 1 over 20. So it will be 4 over 20 and 1 over 20. So 5 over 20. Of course, you can use the calculator for doing these calculations. And finally, it is 1 over 30 t to the power of 4. Okay, and so therefore, gz of t is equal to 1 over 20 plus 1 over 4t plus, this is 5 times 5 is 20, 5 and 5 times it is 12. So it is 5 over 12 t square plus 1 over 4t cube plus 1 over 30 t to the power of 4. Okay. So this is gz of t, and we have to find gz prime of 1. So first of all, let us find the first derivative of this expression. So this is equal to 1 over 4 plus 5 over 12 times 2t plus 1 over 4 times 3t square plus 1 over 30 times 4t cube. Okay, and these two can get cancelled, and okay, and this one can also get cancelled. So it is 1 over 4 and plus 5 over 60 plus 3 over 4t square plus 2 over 15t cube. Okay, so gz prime of t is equal to, sorry, not t1, 1 equal to 1/4 plus 5 over 6 times 1 plus 3 over 4 times 1 square plus 2 over 15 times 1 cube. Okay, so this is equal to 1 over 4 plus 5 over 6 plus 3 over 4 plus 2 over 15. Okay, so you can use your calculator. Let me try to do it orally. The LCM of 4, 6 and 15 should be equal to 60. Okay, so 60, 4 times 15 is 60, so 15 times 1 is 15. And I could have written the numbers, the terms separately. I have just taken the common denominator as 60. You can write the terms separately and add them. I am writing them as a single fraction. Okay, and then 6 times 10 is 60, so 5 times 10 is 50, and 4 times 15, so 3 times 15 is 45, and 15 times 4, so 4 times 2 is 8. So this will be equal to 50 plus 45 is 95. So 95 and 15 and 8 is 23. So it is 118 or equal to 59 over 30. Okay. So they are saying use this result. This is equal to expected value of z, and we have to get the expected value of z. Since this is equal to expected value of z, therefore expected value of z is equal to 59 over 30. Okay, so this is the answer for this part F. Okay, now we had found that gx of t and gy of t. X was the number of red balls and this was the number of tails that were obtained. Okay, so let me write the distribution tables once more quickly. So this was 0, 1 and 2, and this was p of x equal to x. It was 3 over 10. I'm just copying 3 over 5 and 1 over 10, and this one was y 0, 1 and 2, p of y equal to y 1 over 6, half, and 1 over 3. Okay, and z was the sum total of all the x balls and all the tails. Okay, so this is red balls and this is tail. 0, 1 and 2 and this is 0, 1 and 2. So the sum total can be 0, 1, 2. 1 plus 0 is 0, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 0 is 2, 2 plus 1 is 3, and 2 plus 2 is 4. Okay. So now let us construct the probability distribution table of Z. We are seeing the values will be 0, 1, 2, 3 and 4. Okay. And next it is P of Z equal to Z 0. That means red and tail. Red is 0 and tail is 0. Red is 0 is 3 over 10 and tail is 0 is 1 over 6. So this is 1 over 20. Okay. Then Z equal to 1. How can you have Z equal to 1? Either red 0 and tail 1 or red 1 and tail 0. So red equal to 0 was 3 over 10. So 3 over 10, tail equal to 1 is half, plus red equal to 1 is 3 over 5. Tail equal to 0 is 1 over 6. Okay. So this is 3 over 20 plus 1 over 10. 1 over 10 is 2 over 20. So this will be 5 over 20. Okay. So this way you have to fill up these three portions, these three columns. P equal to Z equal to 2. How can you have Z equal to 2? R equal to 0, T equal to 2, or R equal to 2, T equal to 0, or R equal to 1 and T equal to 1. Okay. So you have to do this. For Z equal to 3, you can have R equal to 1, T equal to 2, or R equal to 2 and T equal to 1. And for Z equal to 4, you will be having R equal to 2 and T equal to 2. So you have to use these and this one for filling up these three places. Okay. And then after you get these three places, you can get I would ask you to get the values of these three places and check whether the value of the expected value of Z, the value that we have got, is the same as you are getting over here. You will be multiplying 0 times 1 over 20 plus 1 times 5 over 20. So you see the value that you get for the expected value of Z matches with the expected value of Z that we have found this week. Okay. So we have completed solving this question number 1. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. In our next session, we'll be solving the question number 2 of the same paper. Till then, bye.